Inequalities describe more than one possible answer, so they are useful when a measurement can vary, a choice has limits, or a situation has many acceptable solutions. This lesson connects inequalities to real situations by showing how distance creates ranges, how several conditions overlap on a graph, and how the best choice can be selected from all possible choices. The first idea begins with absolute value because absolute value turns a difference from a target into a distance. An absolute value is a distance. So the absolute value of a number tells how far that number is from zero, and the absolute value of a difference tells how far one value is from another value. And a temperature is meant to be 25 degrees Celsius, but may be off by at most 0.5 degrees. The distance between the actual temperature and 25 is less than or equals to 0.5. That statement is written as the absolute value of T minus 25 is less than or equals to 0.5, and it means the actual temperature stays within 0.5 degrees of the target. A less than or equals to 2 absolute value inequality becomes a middle range. So the absolute value of x minus a is less than or equals to b, means x is between a minus b and a plus b. For the temperature example, the compound inequality says negative 0.5 is less than or equals to t minus 25, which is less than or equals to 0.5. Adding 25 to all three parts keeps the comparison balanced, giving 24.5 is less than or equals to t, which is less than or equals to 25.5. This means the actual temperature can be any value from 24.5 degrees Celsius through 25.5 degrees Celsius. A greater than absolute value inequality creates an outside range because a distance greater than a number can happen on either side of the center. If the absolute value of T minus 25 is greater than 2, then the temperature is more than 2 degrees Celsius away from 25. So T is less than 23 or T is greater than 27. Systems of linear inequalities extend this range idea to a coordinate graph where each inequalities describe a region and the solution is the overlap that satisfies every condition at the same time. In a diet planning situation, let X represent the number of one type of food pellets and Y represent the number of another type pellets. So X and Y must both be greater than or equals to 0 because negative pellets are impossible. If one pellet type gives 2 units of protein and 1 unit of fat, while the other gives 1 unit of protein and 3 units of fat, then the protein condition is x plus y, 2x plus y is greater than or equals to 8. The fat condition is x plus 3y is greater than or equals to 9. So the full system includes the protein condition, the fat condition x greater than or equals to 0 and y greater than or equals to 0. To graph each inequality, its boundary line is drawn by first treating the inequality like an equation, such as 2x plus y equals to 8 or x plus 3y equals to 9. The boundary lines are solid because points exactly on the lines are allowed when the symbol means greater than or equals to. A test point, such as the origin, shows which side of each boundary line works, and because 0 protein and 0 path do not meet the minimum requirements. The correct region is away from the origin for both nutrition inequalities. The feasible region is the overlap of all the allowed regions, and every point in it represents a food combinations that meets the requirements. Linear programming is the use of linear inequalities and linear expressions to find the best value, such as the lowest cost or the highest profit from a feasible region. If the first pellet costs 20 cents and the second pellet costs 30 cents, the total cost is 0.2x plus 0.3y. A key fact of linear programming is that when a best value exists for a straight line cost or profit expressions, it occurs at a corner point of the feasible regions. The important corner points come from the boundary lines and their intersections, including the point with 4 pellets of the first type and 0 of the second pellets, the point with 0 of the first type and 3 of the second, and the intersection of the two nutrition lines. Solving the equations 2x plus y equals to 8 and x plus 3y equals to 9 gives the intersections at x equals to 3 and y equals to 2. The cost at the three corner points are 80 cents, 90 cents, and $1.2. So the minimum cost is 80 cents at 4 pellets of the first type and 0 pellets of the second type. Inequalities can also be solved by algebra alone, as in the absolute value inequalities. The absolute value of 2y plus 1 minus 4 is less than 1. The absolute value part must be isolated first. So adding 4 to both sides gives the absolute value of 2y plus 1 is less than 5. Because this is a less than absolute value inequalities, it becomes the compound inequality. Negative 5 is less than 2y plus 1, which is less than 5. Subtracting 1 from all three parts gives 6. Negative 6 is less than 2y, which is less than 4. And dividing all three parts by positive 2 gives negative 3 is less than y, which is less than 2. This final range means every real number between negative 3 and 2 is a solution, showing how inequalities describe intervals, their directions and regions, instead of only one exact answer.